Hello. Welcome to our webinar. So good afternoon, everyone. So I hope everyone have already had their lunch and everything. So I think we're going to start now. So, okay. The webinar topic for this webinar is going to be integrating reality capture in built environment. So our invited speaker for today is going to be Mr. Haris Mansor. He's the beam cell specialist from Leica Geosystem Technologies from Singapore. So this webinar is going to be hosted by PCSS and then in collaboration with Hexagon and Leica. So Mr. Haris has over 8 years of experience in design and construction, and he worked in level 2 beam project as well. So he's very experienced in beam consultation for AEC industry especially. So he have a very broad experience in integration between digital application. So he is also one of the earliest committee in BIM Institute of Malaysia. So he's a certified trainer, and then of course he's one of the level 3 certified competent technical designer JPK Malaysia. So before we start, so we're going to go to a few house rules for this webinar. So okay, right. For this webinar housekeeping, so this session is being recorded. So for our records, and then we will send the recording to all of you later on after the webinar is done. So make sure that every participant disable their audio, and of course it will be better for us to turn on their camera so that me and Mr. Haris can look at your your face. And of course, if there's any question, you can type it in the chat box at any time, and we will answer it during the Q&A session. So I think I will pass this session to Mr. Haris. So Mr. Haris, how are you today?
I am great. Can you hear me now?
Yeah, I can hear you loud and clear.
Awesome.
Mm.
I think I'm having a sore throat, but I think it makes my voice much handsomer. Okay. So shall I take the session now? Yeah.
Yeah.
All right. So let me share my screen. All right. Let me know if you can see the screen now.
Yeah, we can see it.
Awesome. Okay, so a very good afternoon, everyone. Selamat tengah hari. Right, so just to again, thank you very much, Watson, for the introduction. My name is Haris Mansor, and I am from Leica Geosystem. I am Leica Geosystem part of Hexagon, basically. I am now in our office in Singapore, and actually I had this program or this thing in mind last week that I would like to show you guys our showroom that has, I mean, that we have a 200 years of technology of surveying and how we gather the reality capture, but some unfortunate event. However, I think the content is much more important rather than the intro. Okay, again, I am in Singapore basically. I'm just to share with you a bit on the personal things. I am Malaysian anyway, and I'm staying in JB. And I am, yes, I am one of the 300,000 Malaysian that going up and down from JB to Singapore. So don't worry, we are fine, we are okay, we are happy. Everyone's going back to the normal. Okay, so without further ado, let me just continue with the presentation. Okay, so first of all, what is hexagon geosystem? Hexagon, right? So we are Leica geosystem, part of hexagon. So basically, shaping change or shaping smart change is the driving force behind this our mother company, which is the hexagon, the parent company. Sorry. Okay, so we are basically a digital solution company that is in the pursuit of supporting these macro changes affecting all of us in the society, and presenting to you the new way of doing things to support your transformation in your journey. And of course, digitally, everybody going towards digitalization. So we are actually very proud we are part of this movement. And of course, how do we do this, right? We're doing this by providing you with a continuous information loop that is supported by sensor, right? So as you can see, sensor, of course, we're producing lasers and whatnot that measure and detect with software, right, that is tailored for your industry and your application. So, of course, when it comes to built environment, there are various of software, various of integration that lots of stakeholders would like to know how to deliver how to deliver the information or how to share the information from, for example, from field to the office environment and going back to the field. So I will share with you a little bit on that later. But let me just walk you through a bit on the how we do this. Okay, we use the sensor with software, which allow us to bridge the real world with the digital world and manage and support the dynamic changes that happen every day. Okay, so as you can see, whatever that we have captured in the real world, that is the reality of it. So hence the reality capture, and of course, we bring it into the digital world, which is it will create an actionable information from this information in our industry in architecture, engineering, and construction. Right. So this is basically how we actually go towards it and how we want to actually help the industry. And of course, just a little bit on this R&D overview. Okay, so of course, just we want to let you know that we have roughly Hexagon itself have roughly 4,000 people in R&D, right? And of course, when we say we have 4,000 people in R&D, means we are serious. We don't just make things just for the sake of selling it, but of course, we always emphasize on, we always focus on how our end user would like us to actually let serve them, and basically to let them feel safe with our product and so on. So of course, just to let you know, Hexagon spent almost 400 million euro, spend investing in R&D on annual basis, which means again it's a serious effort. To be more connected to the industry, right? Hexagon serve 8 divisions spanning from agriculture, from the left to the safety infrastructure to the right. So basically, we cover everything. So I do know some of the participants or audience here might be in an AC, but some of you might have any connection in agriculture, geospatial, manufacturing intelligence. So we do have all the solution, the sensor and software technology just to serve it better, all right? Another division is, this is basically just to share with you on in terms of power and energy. Another part of division that we are covered, right? Again, for us, we know that there are 3 needs for the new solution in the construction, right? So of course, number one, the important part is the data integration. Uh, when it comes to the AEC industry, right, there are many stakeholders, from the designer, from the builders, from the end owner, and of course there are millions of information that in passing through from left and right, up and down, and so on. So we are looking at a solution on how we can integrate it, how we can actually deliver the information easily, right? Then number two, we're looking at the seamless workflow. Of course, when we talk about this, is which means that from the design, we gather all this information, say for example, the reality that we capture and everything. So we have to ensure that there is a seamless workflow from one stage to another. It's not something that you have to keep on converting elements, or keep on converting the file just for the sake of accessing this information. So basically, this is the second area that we look into. And the third one is the important one, is actually a simple user-specific solution. So we have invested into a software solution that will make sure our end user will not going to have a hard experience, or a very I mean, we try to providing a simple user experience to all of our customer. All right, so this is basically what we try to focus the three item. And of course, when we talk about moving into digital transformation, everybody would actually know the benefit of it. Of course, we want to make sure that we can deliver the project on time, on budget, and on spec. A part of that is focus. Of course, we're also looking into to improve the productivity. We make sure that all our operations are safer. The important part is actually to get a better and higher accuracy, a better communication, and more innovation. So these are amongst other value to the stakeholders. So we're talking about the owner, the asset, the FM operator, the contractor, and as well as the designer. So how do we look at the solution to this digital construction? Right. So the way we construct our built environment is changing for good, right? So with the inclusion of, as everyone would know, the BIM, the information modeling in the construction process, so the digital workflows are becoming part of everyday life and sites around the world, and I believe it is here to stay, right? And of course, from the start, I think 5, 10 years ago, people will look at BIM as just always talk about model and all. Now everybody's trying to shift their mindset and the workflow to more on processes. So that's why we at Leica System, of course, we are not we are a solution provider. We are more on, I mean, some of you might know that Leica is just more on the hardware and so on. But let me just share with you on how we are here to help you to actually embrace the change if you're not there yet, right? But if you're already in the middle of changes, you have digitalized all your workflow, all your processes and everything. We hope, and I hope, personally, I hope that started from this session, right, from this slide, I hope that everyone and everybody will see that, okay, this is where I need to have in my project. I need to make sure that I can actually fully utilize the digital construction or digitalization process in your own project. So there it is. So let's talk about this digital construction life cycle. Okay, so again, AEC, this is a common, I think, pretty much typical building life cycle, right? But of course, from the Leica Geosystem point of view, all right, so we break it down into 4 segments, right? First, we have the capture. Now, this is where, of course, prior to a designer that going to design the project and all, they will go and actually have a look at how I mean, capture the site, right? They will capture in the sense of probably, typically, they will go with camera. I mean, it depends on the technology that you have, right? But as of now, I think started from past 5 years ago, right? People started to embrace, especially those in Asia, they started to embrace this laser scanning technology to capture the as-is environment. Is it important? So of course, later I will share with you on how this will actually going to give you a better insights in terms of capturing your as-is environment. Then, of course, after that, we have the design. Again, for Leica Geosystem Parahexagon, we do not have a design per se software. But what we have is actually, we try to provide this so-called solution on how to integrate with the as-is data that we have captured. So that's why we have all this information, say, for example, the tree solution that you're looking at right now. Then, of course, this is where most of our solutions shine, right? So to construct. Again, the important part of construct is mainly on where are you going to construct it. All right. So this is where a surveying based technologies such as the one that we have in Leica audio system, we are better to help our end user to integrate the reality capture that they have captured in the first phase, all the way to the designer, and how we are going to make it visible for the contractor to actually construct it. And of course, once you're done and everything, this is basically some of you, I do notice that some of you in facility management, in asset management area. So this is where you will find our solution that I will share a little bit later on how you can maintain, how you can actually use our solution in operation and maintenance stage. Okay, because some of the projects, some of you might just involve in phase two, some of you might just involve started from phase three, and probably everywhere. But let me just share with you how do we integrate this reality capture in each of these phases. First of all, let us look at on how to leverage the reality capture. Okay, so let me share a bit on reality capture. What is reality capture? Okay, so reality capture is a process on how you capture the reality. Quite straightforward, right? So you have your reality, you have whatever you see with your eyes. That is what you want to capture. So this is where some of the misconception that when you see some of the technology in reality capture, you might think that okay, I want to capture the unseen and so on. So of course, we do have there are certain technology that is able to capture the unseen, but when it comes to reality capture, you are capturing what you are seeing. Okay, so of course, once you have captured it, there are many things that you can actually do. But of course, by leveraging the technology that in the reality capture, let me share with you what what Leica Dual System reality capture product portfolio is. Of course, we do have, you can see from the left, you have that meter of scale, right? Then bottom right is the meter of accuracy. So this is where most of our end user, especially professional like all the audience here, we will look at how are you going to fully leverage on the technology that we have, right? So we have those that probably you want to get to the minimum accuracy, you get the bottom left, and then you want to get to the sorry to the minimum, I mean millimeter of accuracy, all the way to the right. You can see the bottom right is the one of the technology that can actually do it faster, but the scale is a bit smaller. All right, so all the way to the higher scale, which is we have the technology that we put on a vehicle, all the way to the airborne. All right, so these are all the technology that you can actually leverage for whoever the professional is, whether you are under civil infrastructure, even if you're under urban planning, all the way to power and plant. So this technology can actually cover almost everything, almost every sector, right? So let me share with you a little bit on how do you can actually grasp in terms of reality capture for new build construction. So this is how you can actually digitalize your way of construction. I mean the way in the construction. So I hope you can hear the audio. Pastor, can you hear the audio? Awesome.
Yeah, we can hear.
Oh, sorry, is it playing? Huh? What happened? Oh. Right. So that is an infographic or info video, I would say, on how you can fully utilize the 360-degree of technology from start to design, in between of construction, and all the way to facility management. Okay, so what I'm going to share with you right now is one of the technology that how I mean that you will be able to rapidly collect all the data, and start to leverage on it. So there you go. Just to let you know, you're not going to see the thing later. So it's just for All right, so that is pretty much on AEC interior. Of course, if you stretch it a bit further, you get exterior as well. And for whatever reason that you want to use it. Now, this is something that I think is quite interesting. I just saw this on Netflix, and they're pretty much used this
I'm Scott
technology.
Seederling with Seederling VFX. We're a 3D capture company. LiDAR stands for light detection and ranging. This is basically the point of light that this machine shoots out, and at that point it creates a point in space. When you do that billions of times like this scanner can do, it basically creates a digital representation of the entire set.
Right. So the keyword is digital representation. So all this while, most probably when a designer would like to actually design, they're based on what they have captured. But so some of it they might just capture things that they can imagine. But as of now, there are technology, not even in film, I would say. Again, the keyword is to capture your or digitalize your reality. So yeah, there it is. So of course, let me just share with you on how this thing happened. So first of all, look at the software convergence. You have the technology, all right? You have the hardware technology, for example, for whatever that we have, whether from the one that you've seen just now, handheld, all the way to the one that we actually put on the vehicle. Of course, the keyword is actually capturing your reality. So, but the important part is actually the software, right? So there are three stages that a user can have to go through, right? First is you prepare it. Nowadays, everybody want to actually make use of the tab or the phone, everything that you can actually access in the palm of your hand. So you can actually use your iPad, for example, to prepare them, and then you export it out. Which you actually manage it. Then of course at certain point you want to collaborate, and then at the end, it's actually how an end user would consume it. Designer would like to consume it in the sense of how to integrate with their own design, their upcoming design, to integrate with the reality capture. Then, of course, for a contractor that would fully utilize the design and they want to make sure that the BIM model and everything is usable for construction. Then, of course, an owner, a facility manager that would only want to access the reality capture, say for example an as-built scan, right, which has all the information. So I will share with you a little bit on how can all the stakeholders access those information. So I would like to share a bit on LGS. LGS is basically a Leica proprietary file format, right? Same goes to, like, for example, in the built environment such as architecture and construction. Say for example a Revit model or a BIM model, for example. So it's not just a model, it must have information within it, right? So you're not just looking at 3D, you're looking at the information that lies within the 3D model of it. So same goes to the point cloud data. So the point cloud data comes in a format of LDS. Of course, this is under us. the Leica geosystem. So within this file format, we will have all the information that is required. For example, the project assignment and metadata, the point cloud and metadata, the geotext and metadata, project setups and metadata, and other project metadata. So these are the information within the point cloud data. So you don't just look at a reality capture that captured and then produce the point cloud data and just that. You will have more than just the points that represent as a Y and Z. You will have a point cloud data that has all the information so that not just a designer, a contractor, and even a facility manager will be able to actually access it anytime they want. Of course, other than the, I mean, in the point cloud data, this is one of the representation that you can actually have. When you go into reality capture, you will have a point cloud data on the top left. You have the ability to actually access the point anywhere you want. Imagine if this is 300 kilometers away from you, you would want to actually access it anytime you want, right? You don't want to go there and do gain the measurement and everything, which is pretty much the mistake that most of the people would actually do. Of course, on the top right, you will have imagery, some of the technology, some of the reality capture technology, not just able to gather the point cloud, but as well as the image as well. Right on the bottom left, some of the technology that able to actually produce thermal images. Of course, this is to sense heat, cold, temperature, and so on. And of course, the bottom right is the most important one, geotech. In a point cloud, just to share with you, in a point cloud, a facility owner would probably don't want to actually see the BIM model. This is mainly for those that has no CAD ability or no CAD skill, right? So they just want to simply double click on the file, you see the file and just navigate just like how you navigate in a game, then access the information. So this is what we call as geotext. So for example, a communication a contractor would like to convey the information that, okay, we have scanned this area, there are something within this area that an owner would actually want to see. So they share the file, they click on the geotext. These are the information that is what the contractor would like to share. So yeah, of course, when we talk about this, I've been talking about different stakeholders for the past 5 minutes. This is how you can actually differentiate, or how stakeholders can actually differentiate themselves in a reality capture environment. So we look at the first team, right? The scan teams. So the scan teams depends on the project, right? Some of the project have their own department, a surveying department that have all the technology to scan together the reality capture. But some of the project might just appoint a consultant to actually to do this. But just to share with you, these are the pyramid that will have that is available or that you will see in the reality capture environment. So we have the scan team on the top, which is they will be the one that actually going to work with this laser scanning technology. They will be the one that actually going to work with the software as well. Then all this information that I have together, they will process, they will pass it over to the CAD or BIM team. So this is where those professional that will produce the 2D layout, for example, then all the way to the BIM model, right? So of course, the BIM model, some of the stages might actually just going to update the BIM model based on the reality that they have captured. So they will actually use different kind of solution. Then all the way to project coordination team, they just want to view the point cloud. Going down, they get, and then you have the management and external teams and client, which probably not going to have time to actually go into certain of the BIM authoring tool just to see the BIM model. Probably some of them might not have the BIMs, the technical skill or CAD skill. They just want to click and explore. So these are the solution, and of course, at the end, the bottom is actually those that going to explore reality capture a bit more further by creating an actionable results when it's needed. I'm talking about creating surfaces from the point cloud data, creating a section from the point cloud data, creating a lot of analysis from the point cloud data. So this is a very specific user, right? So I believe most of the audience are within this pyramid, pretty much within this pyramid of reality capture. Just to share with you a bit on probably if you're in a mega structure, if you're thinking that I'm in a mega structure project and I would like to actually make use of the reality capture solution in my project. So these are the technology that you can actually look into. Then we have those contractor, for example, who like to embrace speed and efficiency. You want to create a highly accurate, complete, usable data for digital construction. Digital construction means that you probably want to use your laser scanner to actually analyze whether your floor is within certain tolerance, the certain tolerance of horizontal, and then the wall within certain tolerance of verticality. So these are the things that is happening right now. Is if I may to share with you. So this is what is happening in Singapore actually. So some of the big contractor actually using this technology to make sure that they are building the project accurately according to the BIM model, right? So they have the BIM model, they want to measure. So this is what we call as verification. Then, of course, for user-specific solutions such as company's owner or facility manager, they don't want to actually work with the BIM model because it's big, it's quite tedious, it's quite technical to actually explore. They just want to have a format that they can actually just double-click and able to actually access those information. So these are the things that you can actually look into. And of course, I've been mentioning about point cloud data. It's nice, it's good. You can capture it while on the go. You can capture it. You can put it on the vehicle. You can even have something like a backpack with it. But what are you going to do with it? All right. So, in terms of reality capture, there are four typical deliverables that you can actually do. Number one is you can actually go for SBIT modeling, right? This is, of course, depends on the project. If there's nothing everywhere, so why would you want to actually SP model it? All right, so you would want to do something like, if I can relate this to MRT project, because I was previously with MRT. So I was fascinated with the data set from our consultant. They've created, they scanned the new line, the MRT line, and then we have, I mean, previously, I mean, back then we have this design data that we would like to integrate with the existing services. So I think it's a monorail, if I'm not mistaken. So monorail is, I think it's in TT Wangsa or City Wangsa. Correct me if I'm wrong, right? So they would like to integrate it. They would like to know where can they actually design the link bridge to the existing project. So imagine if you don't have this technology, you would probably spend months or maybe even a couple of months just to measure, and you probably have to question whether the measurement is correct or not, because I mean, if you get a wrong measurement, basically you will waste another tons of money, right? So SBIT modeling, you model it, then you integrate with your design. Deviation reporting, right? So this is really important for those that are really concerned about the quality of the construction. How flat is the floor, and then how vertical is the wall. These are all important. And another method is, if you allow me to actually share also, MRT has this, MRT Malaysia, right? We have they have this requirement to actually to create a deviation report between the BIM model versus the actual scan data. So for whatever the 50, they would like to know whether the build is within 50 mm tolerance against the BIM model. So these are the things that people start to look into. Number one is because they want to showcase how good their professionalism in terms of constructing. Number two is probably it will involve with a user decision to decide whether they want to maybe cut some of the payment or whatsoever. So, but just to share with you that you can actually do this deviation reporting when you have the point cloud data. Clash detection, quite straightforward, quite easy to actually achieve. The moment when you have the point cloud and the moment when you have the BIM model, of course, every project already have the BIM model. So you have the point cloud data, you combine them, you would know that my design model is already clashes with the existing. So should I shift it? So this will give you an actionable real world data, right? And of course, lastly is the data sharing. So you have the point cloud data. What are you going to do with it? You would share with your end user, you would share with your client and tell them, okay, this is the real things. This is the real, I have construct this. have scanned it, give it to you, and you can actually create an actionable real-world data. So this is what I mentioned just now. You are not just working with a design data that have not built yet. You're working with a reality data, right? So you can have a real dimension, you have the real view, and you can actually interact to make a better decision. So what kind of decision, what kind of data that you're going to have? One is you will have the access, you have a complete 3D picture. Imagine, as I mentioned earlier, right? Imagine if this rooms or this project is 300 kilometers away from you. So it's typical. You can actually just go again and do your measurement whatsoever you want to capture the reality. But again, you can save lots of costs. You can see spaces between spaces whenever you have this. And of course, you technically virtually visit your assets, right? Um, Another thing is actually you, for example, you have the design model, right? You don't have to model everything. As I mentioned earlier, the MRT project, right? So you just model based on what you want to model. Say, for example, this video here, they want to extend the car park of a hotel, for example. So a designer would appreciate this because they already have the reality capture, and they would just design based on where you what they want to actually propose. So only model what you need, as I mentioned, and this is important as to validate your existing models and your plans. Now, a little bit on scan to BIM process. Of course, there are certain technology that you will be able to best fit the geometry to the cloud. You don't have to trace it based on the cloud. Of course, depends on how you scan it. You'll be able to actually create, say, for example, like this one, piping. Really important for plant, professionals. They want to remodel it back. And again, just to share a statistic with you, more than, I think, 68% of the buildings in the world globally, does not have any 3D model. Why is it important? Do you have to 3D model or scan to print everything? Not really, but you have the technology. And of course, as of now, the technology is half manual and half automatic process, but yet still save lots of time and it increase the model productivity. This is one of the, this is a video on how you would actually do the verification. Say, for example, this is a big BIM project, BIM model, right? And what happened is you can actually create, scan the certain area to identify potential issues pre-construction. And even during the construction as well, you would like to know which column or which floor or slab that is off the tolerance. For example, like this one, what this user is actually doing is it separate the point cloud data, the noises from the core elements such as the floor and the column. So what happened is next is try to create some analysis to validate positional accuracy and then come up with this heat map so that the contractor will know which area that is actually sunken down or protruding out or even off the axis, right? And again, it's quite easy to understand the visual heat map, whatever off, whatever minus or whatsoever. So these are the things that is easy for the user to understand. And lastly, of course, for the previous video, more on the for contractor, for designer, this is mainly for facility manager. So as you can see here, you have an image, a high-res image, and you can actually attach this information. So this is what I'm telling about this information within the point cloud data. So you have the ability to actually put in all this data, the specification, the video, the audio, everything, any sort of, there are certain sort of uh, technology or attachment that you can actually put in. But this is more than enough for a model, whoever going to work with this data for the next 100 years, for example. Of course, you wouldn't know whoever have designed it. You probably lost the file, but if you have the point cloud data, which is valid for the next 100 years, anyone can actually access it, and you have all this valuable information. So you can share and collaborate online. You can, again, avoid costly site visits, and you can use and reuse the same 3D data. Now, let me share a little bit on the missing point or some of the in the BIM process, right? So you have the plan, design, build, and manage, right? During the build, some of the information or this BIM information is quite detached or lost. It is because some of the project might go back to the conventional process where the contractor will just build based on the 2D information. So this is what we have. I mean, I think currently it's quite common where you have the ability to view your IFC model in your construction tools, such as this one here. Right, so what you need to do is you just have to access the BIM model, the IFC, I would say, the IFC in these devices. Then what you need to do is, again, as I mentioned, is more on where. So you would like to know where can I build this, or where can I start the wall? Where can I start to do I mean, the starting point of certain element. So this is the common technology that we have in our portfolio as of now, right? Okay, so just share with you again. Fast. So a little bit update on this, I mean, the workflow, the end slide that you've seen just now. So we have developed a new, I mean, based on the technology, it's, as I mentioned, we've spent a lot in terms of investment, hardware and software. So in terms of R&D and so on, so we have developed something that, or the process has been cut into 50%, right? Cut into 50% in terms of integration between the BIM model to the site. So yeah, I think if you like to know more, just let me know. We can actually share with you on how to bring your BIM data into the site. So, but if you really like to know more on how do we embrace or how you can actually integrate your I mean the reality capture in your built environment, of course, when it comes to digital construction, so you can actually go to here, bit.ly digital construction, and you can actually go to see or try to look at all this. Say, for example, the first one on the left is the Changi Airport, and then we also have this how our I mean, if you know port coast in Vietnam, they actually fully utilize the professional in terms of coastal solution. They use the laser scanning technology to digitalize the most of the Vietnam sea line. Then, of course, last is of course, one of the Singapore case study as well, right? So that is pretty much of it. Terima kasih. And yep, there it is.
Right. Terima kasih, Haris, for the sharing. It's a very good sharing session. And then I think for this one, we're gonna start with our Q&A session after this. And then Okay. Is there anyone with any question on the build reality, capture reality in BIM build environment? You can type it in the chat, and I think Harris will.
Yeah,
Harrison, we can answer it. Yeah.
no problem.
Mm.
Any questions from the
Okay.
audience?
Okay. There's a few questions from Corwin Fai. Hi. May I know, can the software able to take in relative mesh model?
To take in reality mesh model. Yes. Okay. So I think Ko Wing Fai, are you talking about importing the mesh model into BIM software such as Revit? If that is yes, there's a way, but just let me remind you that Revit or BIM tools, or they are not really friendly with mesh model, because mesh model has triangulation. Triangulation, of course, uh, the detail, the more detail your mesh model, the more triangulation you will have. It will make your workflow slower. But I bump into one post in LinkedIn. I think you can just Google them, where they share about how this one person can easily bring in a very high poly into Revit. So of course it's not from our solution, but just this is more on the software part. For your project, yes, I think you can just go through LinkedIn. I think there's one post, just search mesh in Revit. I think you'll bump into that post in LinkedIn. Yeah.
Okay. We have another question from Bian. What is the three or most important basic equipment in the arsenal of a relative capture process?
Yeah, interesting. Okay, so as of now, I think the most important is again, it depends on whether you have a surveyor or not in your department, right? In your company. So you can have, say, a handheld, let's say for example, architecture engineering construction. If you just want to achieve a very rapid 2D layout plan, right? So you can actually have this what we call as handheld laser scanner, but okay to go. You can actually just get that, put that in your arsenal. And then you can also have a somewhat much more high detail, right? For example, R3C 360, right? So you can actually use that. You can actually produce up to 2 million points per second, right? What we call as terrestrial laser scanner. So you can have a handheld, you can have terrestrial laser scanner. Then lastly, you can have something like what we call as a UAV, right? A UAV that can actually produce a drone, I would say, a drone that can actually produce all these points, right? So above ground and mobile. So if you have this in your arsenal, oh, you have a very good project.
Okay, thank you for the answer, Mr. Hafiz. So I think, is there anyone else with any question? Perhaps I have a question for you also, Haris.
Yeah,
I think,
no problem.
okay, for let's say a simple project like a auditorium like that, how long does it take for us to do a scanning for the whole? Let's say maybe a school, you know?
It depends
Mm,
on the detail. So usually we always ask, you can have as quick as you want, or you can actually go for months, right? It depends on the details. Say for example, if you just want to have
mm,
if you're into digital transformation of
mm,
the say for example heritage buildings, that will
mm,
take a bit longer time. But we also look at deliverables. Are you going to model it in the BIM authoring tools? Are you going to just mesh it? Or you just want to have a point cloud data, a very detailed point cloud data. So again, you have to a user with a 2 million point per second technology, it will be quick because the coverage is bigger. You can have more points, you have more details. So it could take, I think, let's say for example, an auditorium, a hall, a square, a simple one, you can get it done less than 3 or 4 days. I think this is during working hour. So for maybe half a day. So half a day, 4 days, then you can actually done. Or you
mm.
can actually do it one day only if it is small.
Oh, okay. I think Bian have another question as well. What do you think of the future of reality capture will be in 5 years from now? For example, you mentioned now it's 50 automated and 50 manual. Might it be almost 100% automated in the next 5 years?
Yes, okay. I
That
like
price
this
tag.
question. Okay, so there are discussions circling around I mean end user. All right. Number one is the whether the question that we have in mind is number one, whether the point cloud is enough to represent as a reality capture. That's one thing. If that is enough, then people wouldn't go for creating this 3D model out of the SB, because the point cloud is already dense enough. The point cloud is already there. What we need is actually we just want to have the reality capture of it. But if they're really concerned about the 3D model, the geometry of it, then you would look at, then they will come to the next question, which is when will it be 100%? Okay, so I think I also bump into a post that they have come up with some coding that can automatically convert this point cloud data into a BIM model. We do have like 80%. I mean, we do have a technology that automatically can convert a simple LOD, if you're still using LOD, right? 200, a basic BIM model, right? A basic BIM model. We have the technology to actually convert it. But when it comes to a very technical or very crucial or very hard to design model, then of course a manual procedure will take into place, right? But there is another question, which is mesh enough to represent your B model? Which is, of course, this will go to the previous question that I think who asked this now, Wing Fire asked this now, want to bring in the mesh into their B model. So if the mesh is enough, then if we can find a solution that we can integrate this mesh that represent the reality capture, we integrate the mesh into the beam altering tools, then it will answer everything. So actually it depends on the end user, what kind of deliverables that they want to actually work with. If they want to work with the BIM model, then they have to actually model it. And of course, I think in the next 5 years, there could be an automation. But again, as of now, whatever that you captured is just a point. That point doesn't represent the material, a wall or a floor or anything. Segmentation, yes, but probably the next 5 years we will have the technology that can come close to that. All right. So again, the question, if I just wrap up the question, number one, you have to think whether the point cloud is enough to represent the point cloud data. Number two, if it's not enough, then the B model need to go through a certain modeling requirement, which in hope that in the next 5 years we will have the full automation. And number three, probably the mesh. We might look into mesh, a high density mesh that can actually integrate with the BIM authoring tools. Then that would actually going to solve lots of problems.
Okay, thank you, Haris. And we have another question from Muhammad Karun. What will the most area of industry will benefit by this technology?
Right. Number one is the most area that will benefit from this technology is, as of now, is, I mean, not commonly is the oil and gas, because they have deformation, they experience deformation, they experience changes by nature and so on. They would want to scan every time. Sometimes they have monthly scanning activities or even weekly, the mostly because it's very crucial. Number two that will benefit from this technology is actually the AEC. Right. So just to share with you, according to the, if I'm not mistaken, Construction Information Technology, CITP, is it CITP 4.0 under CIDB? There are 12 technology that is required to be implemented from within 2020 to 2025, and one of it is the 3D laser scanning. So the moment when this has been, I mean, this has been put into by policymaker, so I believe there is a place. So AEC is actually quite growing fast, and I think they should go into this technology and make use of this technology, and fully work with this technology. That's two areas that I would think will have the benefit in terms of using this technology. Oh, another thing is actually the public safety as well, right? I don't know whether there are some public safety professional in here, but I think you should also look into this reality capture, because rather than photo, right? You capture the reality, then basically you can actually work with I mean any policeman or even the court can actually look at the reality, just like CSI kind of things, right?
Mm,
How about
okay.
underground screening? What is the reach? Oh, sorry, I just read it. You can go
Yeah.
ahead, Watson. Go ahead, Watson.
I think we have a question from the floor. So we heard about reality. We're able to improve our daily operation, especially on SBO scan. Is
Hmm?
there any specific criteria that we need to look at, or what are the current obstacles for us to pursue reality capture?
The first half, come again, I
Hmm.
just lost the first half.
Okay. Is there any specific criteria that we need to look at when we heard about it, how our reality capture can improve our daily operations, especially
Ah,
on S-build scan? Yeah.
yeah. Okay, so I think
Mm,
time versus accuracy. If you notice that we have
mm,
that scale just now, right? Up
mm,
the vertical and horizontal scale. So you got the minimum accuracy that you want to the highest to the big accuracy. We're talking about millimeter versus centimeter, and then the scale of the project, whether it is housing or internal, to the let's say mega structure. So if you're somewhere in between, you just look at okay, if I'm in the architectural, engineering,
mm,
and construction industry, most of my project is actually just to scan more on the interior, exterior, and integration or extension of a building and so on. From there, you will know that, okay, these are the accuracy that I can actually work with. Just to share with you, like MRT, they only look at centimeter level of, 12 mm accuracy of the point cloud data. It is because they have to think about the file size of the point cloud data. Point cloud, right? The billion
mm.
point that you're working with, the bigger storage that is required. So find your balance. But whatever it is, just let me know. Let's say, for example, Maris, I'm working with a construction project extension. So what is the best tool that I want to capture rapidly? Or let's say maybe you have ample of time. I have all the time in the world. I can scan as slow as I want. Also, just let me know, and we can actually guide you. So yeah, that's pretty much of it.
Okay. How about a question? I think we take a question from Albert as well. How
Mhm.
about underground scanning? What is the range of coverage scan?
Okay, so we have this thing called ground penetrating radar, right? So ground penetration radar, right? So GPR. So this
Mm,
technology, and we do have the specialist in my office. So, but
mm,
pretty much I know about how this actually, I mean, on the surface. So the depth, there are certain depth they can actually go up to meter level, right? But as of now, what we have in our lineup is up to 800 mm. So that's the depth that you can actually go, the range and coverage scan. Of course, there it is actually they use different kind of technology. But in general, it's just scanning, but it's actually using different radio wave technology that scan whatever underneath whatever unseen underground. But let me know if you would like to know more about this, Mr. Albert. We have a professional that can actually guide you through it.
okay. I think we take another last question, Mr. That one, Haris.
Yeah.
So the one is, does the relative conversion require high-end GPU? Or let's say if the client does not have a high-end GPU, can you guys process the data for them? The data for the
Um,
client.
yeah,
Yes.
I think there are certain end consultant that actually
Mm,
provide that services. So you have the point cloud data. For example. Let's say, for example,
mm,
you just want to find somebody that can just convert everything. You just want to have the B model, right? They're also consultant actually providing that kind of services. But just to share with you, for us, we are manufacturer, we are software, we are IT, information technology company, so we don't provide consultation. But let me know if any of you would say that, okay, do you have anyone in Malaysia or whatsoever? Just let us know. We have partners in Malaysia that know somebody in Malaysia. No worries.
All right. Thank you, Haris. I think this will be the end for our question and answer. And then we're going to thank Mr. Haris so much for your time with us. So for those that want to get the attendance and the certificate, so you guys can scan the QR code, and then of course you guys can we will send the attendance certificate for you guys as well. And then for PCSS, so we do provide BIM consultation services as well in Malaysia. So everyone that want to know more about BIM and want to find consultant or those that can actually do it and specialize in it, so you guys can give us a call as well in PCSS, and you can visit our website and you can contact us through our LinkedIn and our email as well. So I think, Mr. Harry, thank you so much for your time, and
No
hope that
problem.
we can see each other soon, since the
Mm.
borders open up as well. All right.
Yeah, coming in and out every day.
Okay.
Thank you, everyone. Thank you very
Thank-
much. Thank you, PCSS, for the privilege.
All right. Thank you. All right. Bye.
All right,
Thank
bye.
you
Thank
very
you,
much.
everyone.
Okay.
Hello? I think